All right. What is the formula for the axis of symmetry? What is the formula for the axis of symmetry?
Mx plus b.
B divided by 2 times A. There's only one tiny little thing missing. What's missing?
Times 2.
No, not times 2.
X to 0.
It's one little itty-bitty thing missing, but it makes all the difference.
X equals.
There's an equals, but that's not the thing I saw.
Okay.
X equals, there's still something missing. Negative. It is a negative. So when we're writing these, something I want you to make sure of, this x equals part is an essential piece of this. All of these answers need to have x equals and then the number that we find. We can't leave that part off. All right, so on part A right here, what are the values in this quadratic equation for A, B, and C? What are the values for A, B, and C? A is 1, B is 18, C is 81. I'm going to identify my A, B, and C so that I know what I'm substituting in to this formula that we have. What are we putting up on top in the place where B goes? 18. Down on the bottom, I have to do 2 times A. What is our A value? 1. So I'm going to simplify this. What's 2 times 1? So I have 2 on the bottom. I have 18 on the top. What is 18 divided by 2? 9. So I have negative 9. So the answer for this one is x equals negative 9. If you just put negative 9 when I asked for the axis of symmetry, you won't get full points for it. You have to have that x equals part at the beginning. What about on part B? What are the values for A, B, and C here? A is 2, B is 9, and C is 4. So we're going to substitute in what goes up on the top. 9. 2 times 2. Can I simplify that at all? Yep, I would have negative 9 divided by 4. I can leave it just like that. Or if you wanted to put it into your calculator, if you got it as a decimal, what would that be as a decimal? Negative 9 divided by 4. It is negative. What'd you get, Jaden? Jaden, what'd you get? What did you get when you popped it in?
The same thing. I don't know how to do it.
Yeah, negative 2.25. If you use the yellow calculators and you put it in as a fraction, sometimes it'll continue to leave the answer as a fraction. If you want it to give you back a decimal answer on these yellow calculators, right above the enter key, there's a key that looks like arrows that point to the left and to the right. That'll change it into a decimal. So you could write your answer 2 different ways on this one. X equals negative 9 over 4. That would be correct. Or if you wrote your answer in decimal form, x equals negative 2.25. That would also be correct. What are the values for A, B, and C on this last one? A is 3. B is negative 12. And C is 3. So let's sub that in. X equals negative, and what goes up on the top of my fraction? So close. What did you say B was? Negative 12. Down on the bottom, we take 2 and we multiply it by A. What is 2 times A?
3.
Yep, 2 times 3. And I'm hearing people talk about this, and so I love it. We have this negative out in front, and I have a negative up on top. So those 2 pieces together will mean what about my fraction? It is positive. So I have 12 over 6. Can I simplify that at all? to 2. So what is my answer for this one then? X equals 2. So far, so good? All right. We are not taking notes in your books today. There should have been a stapled set of papers at your spot when you came in. That's what we're doing notes on today. We are going to revisit A, H, and K. Do you guys remember back in Module 1 when we learned about A, H, and K? No?
Miss Mo,
Yes, sir.
are we getting our test back today?
No, honey.
We gonna get it back tomorrow?
That is my plan.
All right. They going in tomorrow too?
They should.
What's your lowest grade?
Saturday? You stressed Saturday?
Huh?
You stressed?
No, I'm just asking.
All right.
What's your lowest grades?
Plural?
It's not grade.
Do you just want to know about this class?
Yeah, what's your lowest grade that you got on this?
I am not done grading them, so I can't answer that.
So far. I think I get it.
Let's take notes and then we can talk. All right. In our conversations about A, H, and K, H is always going to be located inside the parentheses. And H is always the opposite of what you see in the equation. And that's why I call it the opposite. Once I know the actual value for H, if H is a positive number, not the opposite, not inside the equation, but H. If H is a positive number, which way did my graph shift? Right. What about if H is a negative number? Then we shift left. You're going to have to write that sentence in. It got chopped off for some reason. If H is less than 0, if it's a negative, the graph shifts left H units. This is the opposite. Does anybody remember what K does? Up and down. So if K is a positive number, we shift up. If K is a negative number, we shift down. Nothing tricky, nothing fancy about K. It's always going to be on the end after everything else. Never inside parentheses, and it is never the opposite. And then we come to A. If A is a negative number, the graph reflects over the x-axis. What does absolute value mean again? Distance from 0. So this next bullet point says, if the distance from 0 for our A value is more than 1, if you take more than 1 hop to the right or more than 1 hop to the left for your A value, then the graph is going to be vertically stretched. If the distance away from 0, the absolute value of the absolute value of A, is in between 0 and 1, so you didn't go very far away from 0, you're right close to it, the graph is vertically compressed. So far, so good? We're going to look at the bottom part of the page now. We're actually going to do problem number 2 before we do problem number 1 on the bottom side, or bottom half of the front page. Oop, too far. I want to look at this graph. Oh, sorry. There's one thing I want you guys to add here. Almost forgot. Add this right here. The vertex will always be HK. When it's written in this form, when it's written in AHK form, that vertex will be HK. Now I'm ready to look down at the bottom part of the page. I want you to look at that graph there. Can you tell me where the vertex is for that graph? What the ordered pair is? 1, -4, right down here. This graph has not been stretched or compressed at all. I'm not going to go into how I know that. When you guys need to figure that out, I'll show you how to figure it out at that point. I just want to practice right now. We're going to write this in vertex form. Vertex form is y equals a times x minus h squared plus k. Our a value on this is 1. And when the a value is 1, nothing changes. I don't need to write it down. What should I put after the minus sign? The 1, because this is my h value. So I'm going to put a 1 right here. And then we square it. What should I put after the parentheses that are squared? -4 minus 4. Because the y part of my ordered pair is my k value. So we took h, we put it in h's spot right here. We took our k, we put it in k's spot right here. A was 1, so we didn't have to write it down. With that in mind, I want to now go back and answer question number 1. Looking at this equation right here, can you tell me where the vertex of this is? Four, 3. Why is it not -4, 3? Yeah, this guy right here, don't forget, this is the opposite. So if I want to know what h actually is, I have to make it the opposite sign there. So our vertex is at 4, 3. We're going to take this parabola right here, and we're going to shift it 5 units to the right. How would that change the vertex? If I go to the right, am I going to be adding or subtracting things? Think about your number line. If I'm standing at 4 and I move to the right 5 units, where am I now? I'm at 9. So I'm going to add 5 to that. 5 units to the right, right here. What about if I shift it 2 units down? What's that going to affect? The y. What would I do if I'm moving down? I was at 3 and I'm moving down 2. I'm going to subtract 2. So where is our new vertex then? At 9, 1. Did they say anything about a new stretch or a new compression? So all the stuff that A controls, none of that changed. They didn't say anything about any changes there. So I'm going to write this new equation. It's going to look almost exactly like the old equation, but we have a different value here and here because our vertex changed. So it's still y equals 2, because we didn't get a new stretch, we didn't get a new compression. So it's exactly what I had before. Is it still x minus 4? X minus 9 now. Still a plus 3 on the end? Plus 1 on the end. My new vertex changed these two numbers right here. Nothing else about it changed. I want to do some practice graphing with this. That's what we're going to spend the rest of our time on today. Go ahead and flip the paper over. I want to make sure that we can identify our vertex first before we actually graph. Look at number 3 with me. What's the A value there? -1. So A is -1. Is this H? No, that's the opposite. So what is H then? H is -7. What is this -3 on the end then?
K.
That's K. Which pieces make my vertex? H and K. So what is the vertex for this parabola? -7, -3. If H is -7, which way did I go? Left. How far? 7. So compared to the parent, this has been shifted left 7. What did the K value do to it? Down 3. I've talked about what H did to it. I've talked about what K did to it. Who have we not talked about yet? A. A is -1. If I multiply something by just 1, does it get bigger, smaller, or stay the same? Stays the same. If I multiply by a -1, what happens to it? It just changes negative, right? So if my A value is -1, it's going to take all of my numbers and change them negative. It's going to flip them over. It's going to reflect over the x-axis. Let's do another one together, and then I'm going to have you guys try one by yourself. On number 4, what's my A? 2. What's my H? -3. This is the opposite, and so H is -3. What's K? 2. So where's my vertex? -3, 2. How would you describe in words what H is doing to my graph? Left 3. Up 2 because of K. We still need to talk about A. If I multiply a number by 2, does it get bigger, smaller, or stay the same? Bigger. So this is a vertical stretch. This is vertically stretched by 2. I want you guys to do number 5 on your own. Take about a minute. Identify your AH and K. Write down your vertex, and then write out in words how this has transformed from the parent.
Wait, we do both of them?
Oh, no, just the one. What's your A value? A value is 1/4. What is H? 10. H is 10 because this is the opposite. So what's K? 13. Where's my vertex then?
It'll be 10, 13.
10, 13. How would you describe this transformation?
Right 10, up 13.
Right 10, up 13. So close. If you multiply a number by 1/4, does it get bigger, smaller, or stay the same? Smaller. So this would be a vertical compression. Compression is when things get smaller. Stretch is when things get bigger. So this is vertical. Yep. Anytime it is a fraction, it will get smaller. Vertically compressed. By 1/4. All right, this last one we're going to do real quick. Where's the vertex on this guy? -4, -2. How would you describe that then? Left 4 down 2. What's the A value here? 1. There's no number there. So A is 1. If you multiply a number by 1, does it get bigger, get smaller, or stay the same? Stays the same. If I'm describing how things are different, and when I multiply by 1, nothing is different, do I have to say anything about it?
No.
No.
Hello, Nellie. Do you remember what you got from the fundraiser?
Possibly. I ordered from 3 different people, and so I have to remember what I got from the other 2 people. But then I can narrow it down from there. I should know by tomorrow, because I can check with my niece and my daughter.
Things come in today,
Okay.
so like I need to figure it out.
Like I said, I know the 3 things that I ordered, so I'll just need to narrow it down. Did the website not tell you who ordered what?
I didn't check the website.
Okay, I'll check and see if I can find out.
Okay.
All right. You're welcome.
Good day.
You too. So yeah, right here, if A is 1, you said nothing changes if I multiply by 1, so I don't need to say anything over here because nothing changed because of that.
So you just leave it like that?
We just leave it like that. This is my only description of my transformation. Yes, ma'am. Number 3, good question. Here it wasn't a 1, it was a -1. Yep. Negative will make it reflect. If it's a positive 1, nothing changes. If it's a -1, it reflects. Let's go look at number 7. Finally, some graphing stuff. We're going to graph the parent first. So our parent function is this guy right here. F of x equals x squared, or y equals x squared. Function notation and y are interchangeable. This right here means the exact same thing as y. All right. I'm going to come down here to this table. I'm going to draw this line over to connect them. I'm going to put x over here, and I'm going to put y over here. Yesterday when we were graphing, we put the vertex right in the center of the table. If you look at this parent, h and k gives me my vertex. What's h and k here? They don't have them. So if it doesn't have an h, what number would it be? 0. If it doesn't have a k, what number would it be? 0. So our vertex is 0, 0. I'm going to put that right in the middle of the table. 0, 0, right here. And then we talked about how we pick our other x's. I think about on a number line, I want some numbers that come before this and some numbers that come after it. What comes before 0 on the number line? What's on the left side of it?
-1.
-1. Give me another number. -2. So -1, -2. Give me a couple numbers that come after it on the number line. 1 and 2. And then yesterday, to get our y's, we took these and we substituted them back in. What does it tell me we're going to be doing to the x's? We're going to substitute and then square them. What does it mean to square something? Multiply it by itself. So I'm going to take -2 and I'm going to square it. I'm going to multiply it by itself. What is -2 times itself? +4. What about when I do the next x value? If I do -1 times itself, we get a +1. What's the next thing I'm going to multiply by itself? +1. What's +1 times itself? 1. We've started reflecting. Do you guys remember when we talked about the reflections yesterday? We're reflecting on the other side of our vertex. What's this last number going to be? 4. 2 times 2 is 4, or I could look at it as a reflection. We're going to go and plot those points. That's my parent function. So -2, 4, -1, 1, 0, 0. That was not an invitation to just put it in your lap. You need to put it away, sir. 1, 1. And 2, 4. I took this x and this y and I plotted it as an ordered pair. This x and this y and plotted it as an ordered pair. And then I get my U shape here. Pop some arrows on the ends. What's the domain for that graph? The domain for my parent. What are all the things I'm allowed to use for x? What were we doing to the x's? Squaring them. What numbers are you allowed to square? Can we square negative numbers? Yeah? If you put decimals into your calculator, could you square them? Can we do it with whole numbers? Are there any restrictions to things that we're allowed to square? No, I can do anything I want to. So how do I say that? All real numbers. -infinity to +infinity is all real numbers. You can put the R, yes. A lot of times you'll see this notation on the homework. This is what it's going to look like, but it means the same thing as all real numbers. Does this parabola have a maximum or a minimum? Minimum. When I go to write my range, we always write the minimum first, and then we write the maximum. What is the minimum? What's the smallest y? 0. So I've got a bracket and 0. Infinity. Why infinity? There is no maximum. It keeps going. Let's start talking about this transformed function now. Here's the transformation that they gave me right up here. What are the values for A, H, and K? A is 1. H is 2. K is -4. So how would I describe that transformation then? Right 2. What else? Down 4. Do I have to say anything about A? No. A is 1. If I multiply something by 1, it stays the same. If I go to the right 2, does that affect my x's or my y's? X. If I'm going to the right, would I be adding or subtracting? Adding. So I'm going to add 2 to each of these. So if I add 2 to each one of those, if I'm standing at -2 on the number line, and I move to the right 2, I'm at 0. What about if I had been standing at -1 and I moved to the right 2? I'd be at 1 now. If I was standing at 0 and I moved to the right 2, 2. What about if I'd been standing at 1? Then it would move to 3. And if I'd been standing at 2, it would move to 4. What was our A value? 1. A controls things stretching, compressing, and reflecting. If I'm stretching or compressing things, does that affect the x's or the y's? The y's. We multiply our A value to the y's only. But they're all going to stay the same because A is 1. Is there anything else that would affect my y values? K. What did we say K was doing to it? Shifting it down how far? Down 4. Do I add or subtract to take it down? Subtract, so I'm going to -4. What's 4 times 1? 4. And then -4, 0. What's 1 times 1? 1. -4, -3. What's 0 times 1? 0. -4, -4. What happens after that? They start to repeat, right? They're going to be a reflection on the other side. So I get -3 again, and I get a 0 again. Or I can pop them in my calculator to verify that. These are the points we are going to plot for our transformation. So this guy that we just did, yep. There's our parent. Transformation, I need a point at 0, 0. I need a point at 1, -3, at 2, -4, 3, -3, and at 4, 0. And then I can get my U shape through there. So here's my transformation. What is the domain for that transformation? What was the domain for my parent? All real numbers. Same domain for my transformation. All real numbers. Does this transformed function, the red one, does it have a maximum or a minimum? Has a minimum. Where is that minimum? -4. It's always my smallest y value. Does it have a maximum at all? Keeps going. How do I write that then? Goes to infinity. It has arrows up on the top. So everybody should be on the next sheet of paper. We are going to graph the parent function. This is the parent function for all of our parabolas. Every single parabola has the same ancestor. This is the formula for it. This is exactly the same as y equals x squared. If you see function notation here, that's the same thing as y. To get this parent graphed, I'm going to come down here. I'm going to connect these two together. I'm going to put x over here and y over here. Do you remember yesterday when we were graphing, we put the vertex right in the middle? The vertex is HK. What's H on this? 0. What's K? 0. So I'm going to put 0, 0 right in the middle of my table, right here. We have to pick out some other values for x, and then we're going to plug them in here to see what we get for y. The way we pick out the other values for x, I want you to think about a number line. If 0 is right here, I want a couple things on this side. What are some things that are to the left of 0? -1 and -2. So I'm going to put those in my table. -1 and -2. I want a couple things on the right side of 0. What's on the right side of 0? +1, +2. So I always put the vertex in the very middle, and then we do a couple things on the left, a couple things on the right. I said we're going to take these x's, we're going to plug them into the parent. We're going to substitute in. What does it mean to square something? Multiply it by itself. So I'm taking -2 and squaring it. I'm taking -2 and multiplying it by itself. What do I get? Negative times a negative gives me a +4. Yes, sir. Yes, you may. What about when I do the exact same thing but with -1? I'm going to take -1 and square it, multiply it by itself. I get a +1 back. Here's my vertex. What's going to happen on the other side of my vertex? They're going to repeat themselves. If I take 1 and square it, I get 1. If I take 2 and square it, I get what? 4. Yesterday we talked about how that axis of symmetry that runs right through my vertex, it reflects on either side of my vertex. Do you guys see that happening? That will always happen with parabolas. Let's go plot these points. So I have -2, 4 as a point. I have -1, 1 as a point. Where's our vertex again? 0, 0. Where's my next point? +1, +1, right here. This x with this y. And where's the last point? +2, +4, right here. So now I'm going to connect these together to make that U shape. This is our parent function. What's the domain of our parent function? Yes. The domain of our parent function is going to be -∞ to +∞. That is the same thing as all real numbers. I want to make sure that we know those are interchangeable, because a lot of times on the homework, if it's all real numbers, they'll write it that way. If you're writing it out for me and you write all real numbers, or you do that R symbol, that's okay. But I want to make sure that we can recognize it all the different ways. Does this parabola, this parent, have a maximum or a minimum? Minimum. It has a lowest point. When I write the range, we always write the lowest first and then the highest. Where is that minimum? What is the y part of the lowest point? 0. So I have a bracket and a 0. Does this graph have a maximum? No. It's got arrows on the ends of it, though. So what would I put for the maximum? Yes, infinity. All right. So now I'm going to come up here and look at this. Can you tell me the values for AH and K here? A is 2. H is positive 4. K is positive 2. What is H going to do to this graph if it's a positive 4? Make it go to the right 4. What is K doing to my graph? Up 2. My A value is a positive 2. If I multiply things by 2, do they get bigger, smaller, or stay the same? Bigger. So this would be a vertical stretch. So vertically stretched by 2. Here's how we're going to graph this transformation. We said it in words. Now I have to figure out what to do with that so that I can make it form my graph. Which of these pieces affects my x values? Which way does the x-axis go? Left and right. Which thing is affecting left and right? Right 4, my h value. If I'm going to shift things to the right, would I add or subtract? Add. I'm going to add my h to all of these. So I'm going to add 4 to all of these. That's going to give me my new x's. If I was standing at -2 on the number line, and then I moved to the right 4 spaces, where am I now? Positive 2. What about if I was standing at -1 on the number line, and then I moved to the right 4 spaces? Now I'm at 3. What about if I was standing at 0, and I moved to the right 4 spaces? Now I'm at 4. Are you guys seeing a pattern happen? What's the next number? 5. And then 6. Those are my new x's. We took all the old x's and we shifted them right 4 on the number line. Everybody just got shifted 4. For my y's, if I stretch something vertically this way, does that affect the x's or the y's? The y's. I'm going to take all the y's and we're going to multiply them by that a value. So everybody gets multiplied by 2, which makes everybody bigger or smaller? Bigger. And then we said we're going to shift up 2. What would I do to my y's if I want them to go up now? Add 2 to everybody. Go ahead and clip it up. So let's write down our new y's. We're going to do these operations right here, and we're going to see what we get. So first I do 4 times 2. What's 4 times 2? 8. Plus 2. 10. 1 times 2. 2. Plus 2. 4. 0 times 2. Plus 2. 2. What's going to happen with these next 2 numbers? It's going to be the same as up above, because remember it reflects on either side of my vertex. So we're going to get 4 and 10. Where did we say our vertex was going to be? What was HK? 4 for my H and 2 for my K, right? Look right in the middle of my table. There's my vertex. That's not a mistake. We put the parent vertex there, and then we did our transformation, so our transformed vertex is now in the middle. 4, 2, that's right here. What other points do I need to plot? 2, 10, that's right up here. What else? 3, 4, right here. What else do I need? 5, 4, there's one of my reflections. It's this guy right here. And then 6 and 10, that's a reflection of this point right here. Can I draw a U through those points? Yes, I can. Kind of squiggly, but it works. What would my domain be for this? All real numbers, negative infinity to positive infinity. All real numbers. Does this red transformed graph have a maximum or a minimum? Minimum. When I go to write the range, we always write the minimum first. And when I say minimum, I mean the y part of that ordered pair. What is my minimum value? 2. I want the y part of this point right here. That's the lowest it goes. So 2. What's the maximum of this graph? Infinity, because we got arrows on the end. It goes on forever. Nice work. Please make sure you're on the right problem. The parent function is exactly the same. Same exact parent function. So I'm going to do my table for my parent function. What was the vertex for the parent again? What was the HK? 0, 0. Right in the middle of my table is where I put the vertex. Couple points on either side. What comes before 0 on the number line? -1. What comes before -1? -2. We're on number 9 on the next side, on the next piece of paper. What comes after 0 on the number line? 1 and 2. And what are we going to do to each of these numbers when I plug it into the parent? Times it not by 2, times it by itself. So what happens when I do -2 times itself? I get 4, not -4. Because remember, negative times a negative gives me a positive. And then 1. What happens on the other side of this? 1 and 4, because it reflects. Whatever I have up here, it's going to reflect over my vertex. Let's go plot those points. Yep. We substitute into the parent function. Parent function said take the x's and square them. What's our... This is the same parent. The parent for my quadratic always stays the same. Parents can have lots of kids, but they are still the parent. What is the domain for this?
Negative infinity and positive.
Yes, all real numbers, negative infinity to positive infinity. What's the range?
And then 0 and positive infinity.
0 to positive infinity.
Yeah.
Every single parabola has this as the parent.
Yeah.
This is the parent for every parabola. Anytime they say sketch the parent, that's this guy. Every single time. I want to come and look at this transformation now. This guy's got a whole lot going on here. What's the A value? A is, I'm sorry, I heard negative, but then I didn't hear the rest. Negative 1 over 3. What is our value for H? Negative 3. What's our value for K? Also negative 3. Because remember, what I see in here is the opposite. All right. Let's see if we can describe this transformation. What's H doing to my graph?
It's going left.
Left 3.
Yeah.
What is K doing to the graph? Down 3. Get the easy ones out of the way. A is the thing that I think looks like a mess. There's two things going on with A.
Compressed.
It's going to be compressed. Why?
Because it's a fraction.
Because it's a fraction. Vertically
And it's
compressed.
gonna be reflected over the x-axis.
Why?
Because it's negative.
Because it's negative. So vertically compressed and reflected. Over the x-axis. Both of these pieces are happening because of A. I agree, A is doing the most right now. Which of these things actually affect my x's? Which piece affects the x?
The H.
H, left 3. That's the only thing that's affecting my x. Yep, we're going to minus 3 from all of these. So negative 3, negative 3, negative 3, because we want to make them all go to the left. All right, so if I was at negative 2 on the number line, and then I went to the left 3 places,
Negative 5.
now I'm at negative 5. What about if I was at negative 1,
Negative 4.
and I went left 3 places? I'd be at negative 4. What if I had been standing at 0 and then I went left 3? Negative 3. And then negative 2. And lastly,
Negative 1.
negative 1. Are you guys noticing a pattern with our x's? They're going to be counting by ones. All I'm doing is shifting them all to the left. The previous problem, we shifted them all to the right. We're going to multiply A next. We multiply which piece, the x or the y?
Negative 1/3.
Yep. Negative 1/3 gets multiplied to all of these guys.
And then you got subtracted by 13.
Why?
Because the K.
Yeah. So first we multiply by our A value. That'll do any stretching, compressing, reflecting. And then we have to shift everybody down 3. And I'm going to bring around some calculators so that we can finish this up. Yes, there is homework.
Isn't it due tomorrow?
Yes. All right, so I want to practice substituting into our calculator, plugging into our calculators here.
Is there gonna be more added to this before?
More added to what we're doing. Nope. This is the hardest it gets
Ooh. Pass it.
for what we're doing today. Tomorrow we build off this idea, but it's the same basic idea.
What's the next test?
Next test is Thursday, October, I think it's 13th. It's the Thursday before fall break
Oh, okay.
is the next test.
So that's like a month, almost like 4 weeks. It's basically 4 weeks.
Fall break is like third week in October, I think. All right.
Well, I'm getting this one.
Let's plug some things in our calculators. In your yellow calculator, 4 times negative 1 divided by 3 minus 3. It comes out gross. That's okay. 4 times negative 1 divided by 3 minus 3. Everybody should be typing this into their calculators with me. 4
Negative 4.3.
times negative 1 divided by 3 minus 3. You said negative 4.3?
I thought we did going to fractions.
You can use the fraction key. You can use the division key. It either says,
Is
Y'all
it
not doing it
negative
right.
5 over 3?
Let me do it, bro.
hold on, let me look.
I got a negative 13.
Yes, hit enter.
Negative 13.
Oh, wait, you forgot the negative
Is it
1/3.
going to be negative 5 over 3?
I got
It
negative
is
13
not
over
negative 5 over 3. You got negative what?
13 over 3.
Negative 13 over 3. Okay, show that to me on your calculator because that's not wrong.
Okay, so
How was it?
I got it right here. Negative 13
All right.
over 3.
So here's
Yeah.
how you change it into its decimal form now. Do you see this key right above enter?
Yeah.
Hit that.
Boom.
Now it's a decimal.
okay.
Boom.
Guys, type it into your calculator with me. If it gives you a fraction,
I got negative 40.
What? Y'all not
Hold
putting
on.
it in right.
She's not doing it.
the button right above enter now.
Negative 13.
Hit the button right
Because
above
it is
enter.
Right
negative
answer.
13 over 3.
No, it's not. The answer is
When you
It's negative 13 over 3.
Negative 13 over 3 is correct.
What? I thought it was negative 4.3, and then the second one negative 3.3.
Yeah, it is negative 4.
That is also correct.
Oh.
Yeah.
Negative 13 over 3 is the same thing as negative 4.33333.
But I'm corrected.
I'm glad you're using your head though.
Bro, my answer is better.
All right.
A decimal always better than a fraction.
No,
No, it's not.
No, it's not.
Oh.
Why? Why you say no?
because it's not.
Easier, bro.
A decimal easier to write than a fraction.
Easier to find.
Not necessarily. It is going to be easier for us to graph.
Yeah, graph it, everything.
So I'm going to write it down as a decimal because it's easier for me to graph it as a decimal.
Oh, this calculator is sweet.
What happens when we do 1 times negative 1 divided by 3 minus 3?
3.3.
Negative 3.3 repeating.
I know, right? I'm on the roll.
And I'm gonna guess
All right.
it's gonna be negative 2.3.
No, it's not. It's going to be 0 and then negative 3.3 again. Use your noggin.
Oh, yeah.
You're both wrong.
What?
Wait, it's gonna be negative 3. It's gonna be negative 3.
Why?
Cause 0 times a fraction is gonna be 0, and then you're gonna have to do
Yeah.
negative.
I'm talking about the one
0
after.
times anything, but this is the next one we were getting to.
Oh, I thought that was
0 times anything is 0. So I have 0 minus 3.
Yeah.
Look back at this thing.
Oh.
Look all the way back at the beginning. Where's our vertex?
Oh, it's right there.
What's our vertex?
Negative 3.
Negative 3.
3.
Negative 3. Look what just showed up in the middle of our table.
Oh.
There's my vertex.
So I got a question.
Yes, sir.
In the middle, if you don't get the vertex, is it wrong?
Yes, because it's going to throw your whole graph off.
If you don't get the vertex, it's gonna be wrong, right?
If
Yes.
you did the H, the A, and the K part right, the vertex will be in the middle.
Okay.
Oh,
So-
yeah. that's-
Always.
All right.
No, but then, let's say what he's saying makes sense, and then you get the vertex wrong. You're going to have the vertex in a random place, and then the rest of the graph in a whole nother, we're in the right spot. You see what I'm
What
saying?
are
Yeah.
you talking about, bro?
Huh? Bro, she know what I'm talking about. That's all that matters.
Alrighty.
Oh, it's probably right.
What's going to happen down here?
Negative 3.3,
No.
and then negative 4.3. Which
Why?
one? Because it's a reflected.
It's a reflection, so whatever I got up here, I'm going to get those same numbers
Right,
reflected down here. So negative 3.3,
Yeah, the honey.
negative 4.3. I'm ballparking with my fractions because I need to just estimate where they're going to show up on my graph.
Negative 3, negative.
All right, so negative 5. I know where to go to negative 5 on the x-axis. That's right here. And then it's negative 4.3. Well, here's negative 5, negative 4. If I wanted negative 4.3, it's going to be just a little bit below that.
Yeah, that's what I did.
Just a little bit below. My next point -4, -3.3. It's going to be -4, and then just a little bit below the
You
-3.
did the decimal move. I mean, I said the decimal.
Yeah,
move.
I had to scoot it over. I put him in the wrong spot, so I fixed it. Where's the vertex? That's the easy one.
-3, -3.
-3, -3. And then we're going to see those points reflected on the other side. So -2, -3.3, -1, -4.3. What do you notice about all those dots? They're real squished together, aren't they?
Yeah, they're compressed.
What did we say was happening?
Vertically compressed.
Vertically compressed. What else do you notice about this graph?
So stretch is more narrow and then compress is more like.
That is exactly right, ma'am. Stretched is going to end up looking more narrow. Compressed is going to end up looking wider. What's our domain?
For the one that we just grabbed.
For the one that we just graphed for our transformation. All real numbers. Domain is all real numbers, -infinity to +infinity. This one that we just graphed, the one that I've got here in red, the upside down squished one, does that have a maximum or a minimum? Maximum. When I go to write my range, it's always the minimum first. What's the minimum? But it's going down, so I write -infinity because it's going down. It's always the minimum first, and then I write the maximum. Maximum is that highest point. It's my highest y value. -3. This is the absolute hardest example I could think of because those y values came out really gross. This is as hard as this gets. All right, so what I want you guys to take note of, on the very back side of this packet, there are 2 graphing problems. You guys are going to do those 2 graphing problems for homework. Then there are book problems too. Those you'll do on the computer. You're going to do 2 problems by hand on paper. Do you guys remember yesterday towards the end of class I told you now we can get to the assignments just in Canvas?
Yeah.
Do you want me to show you one more time?
No, it's on
That's
McGraw-Hill.
okay.
You go to no, not on McGraw-Hill. It's
It's
on
on
Canvas,
Canvas.
and then you scroll down to,
Yeah.
and then it's on McGraw-Hill on the page.
Yes. It'll bring up McGraw-Hill inside Canvas, but all you have to do now to get to the homework inside Canvas is just click on that link. If you're still used to going through McGraw-Hill, you can still get to it that way. But you got a one-stop shop now in Canvas. You can go do it right through Canvas. Right. So book problems, and then those 2 graphing problems that are on the back side of the paper.
You leave that for this.
Yeah, go ahead and leave them out.